initial basic feasible solution using least cost method and Vogel's approximation method. So what is the transportation problem? Again, I am giving an overview. Sometimes it is required to transport same goods from different resources or sources to different destinations in such a manner that total cost of transportation is minimum under the condition that goods can be transported from one source to more than one destinations, as well as destinations can receive the goods from more than one sources, and the per unit cost of transporting goods from different sources to different destinations may be different. The place where goods are prepared or kept for delivery, like go down factories, are called as sources, and the places where items is sold, like shops, etc., are called as destinations. The availability and demand are simultaneously called as rim requirement. Any transportation problem can be solved by using simplex or other methods defined for linear programming problem, as we can write transportation problem as a special case of linear programming problem. But by solving the transportation problem by means of simplex method is very lengthy calculations. So the methods especially defined for transportation problems are used. Any transportation problem is solved in two steps. One is called as northwest corner, sorry, in two steps. One is called as obtaining initial basic feasible solution by using any of three methods: northwest corner method, matrix minimum method, or Vogel's approximation method. There are three methods for obtaining initial basic feasible solution. And for obtaining optimum solution, one is called as method of multipliers and other is called as stepping stone method. So there are two methods which are used for obtaining optimum solution. Method of multiplier, also called as Modi method, or you can say modified distribution method, and other is called as stepping stone method. So northwest corner method was already discussed. Now we would discuss about other two methods. One is called as least cost method and other is called as Vogel's approximation method. Now thus, before obtaining initial basic feasible solution by using any method, following two checks are used. Number one, whether the problem is balanced or not. That means the total of availability is equals to total of demand. If not, dummy row or column is added, and demand for that row or column will be the difference of the total demand and total availability, and cost in all the cells of dummy row or dummy column will always be zero. Second check is made for the problem, that the problem is of minimization type or not. If it is a minimization type, then there is no problem. But if it is not of minimization type, that is, it is maximization type, that is, profit is given into the transportation table, then it is converted into the minimization type, either by multiplying all the profits by -1 or by finding the maximum profit and subtracting all the profits from it. The checks for balance transportation problem and minimization type problem is performed in the same order as given. If order is changed, the solution will be misleading. Now for obtaining initial basic feasible solution, we consider following example, which is taken from the book Operations Research by P.K. Gupta, Manmohan and Kanti Suru. So here it is given that solve the following transportation problem with transportation table consisting of per unit transportation cost. So first we can apply two checks, total availability and total demand. So total availability is 1850 and total requirement is also 1850. So our problem is balanced, and as it is mentioned, per unit transportation cost. That means cost is always try to minimize, therefore the problem is of minimization type. So there is no changes to be made. Now the steps for initial basic feasible solution using least cost method. Least cost method is also called as matrix minima method. It has two steps. One, first step is select the cell having minimum or least cost among all the cells. Allocate the minimum of availability at demand corresponding to that cell into it, and subtract the allocated quantity from both the corresponding availability and demand. The second step is repeat the step 1 excluding the row or columns for which rim requirement is fulfilled till all the allocations are made. And in case of tie among least cost, that means two or more costs are minimum and equal. In that case, any of cost can be preferred. There is no rule which one should be preferred, any of that should be preferred. So first we write the problem into the form of following table. Here you can see small rectangles are made. Here we write the allocations or quantity that should be transported according to least cost method. So first we select the minimum cost among these costs. So we can see that here 3 is minimum among all the costs. No cost is smaller than 3. So first allocation is made in this cell. Here the availability is 350 and demand is 200. So minimum of these two quantity is 200. So we write 200 in this cell. And when we write 200 in this cell, that quantity would subtracted from the availability as well as demand. So after subtracting the quantity 200 from the availability, the remaining availability would become 150 and the remaining requirement will become 0. Here you can see it will become 0. Now after this, since the demand for fourth column is fulfilled, that means rim requirement would become 0. We ignore this column or eliminate this column and then find a minimum cost in remaining first three columns. Now after 3, the next minimum is 4. You can see 4 is in two places, A and 1, that means this place, and C comma 2, that means at this place. So we can select any of these two. I am selecting this one first, that means first column, and corresponding to this cell the minimum requirement is, sorry, the requirement is 250 and availability is 500. So minimum of these two quantities 250 and 500 is 250. So we write 250 in this rectangle and subtract simultaneously from the requirement and availability. So here 250 and remaining availability become 250 and remaining requirement would become 0. Now after this, the rim requirement for this column, that is first column, and for fourth column the rim requirement would become 0. Now we select next minimum cost among column 2 and column 3 and all the rows. So next minimum is 4. So you can see by selecting first this one, in next step we can select next minimum quantity, which is again 4, and here the availability is 300 and requirement is 350. So in this rectangle we write 300 and simultaneously subtract 300 from both the availability and the requirement. So here 300 comes out and remaining requirement will become 50 and availability will become 0. Now first column, fourth column and third row is ignored. That means second column and third column is considered, as well as first row, second row and fourth row would be considered for next allocation. Now next minimum is 6. For corresponding to this 6, the availability is 250 and requirement is 50. So next allocation is made in this rectangle will be 50. And simultaneously it is subtracted from the remaining requirement and availability. So in that situation, when 50 would allocated to the cell A comma 2, the remaining availability would become 200 and the remaining requirement would become 0. Now we have only one column remain which have availability 1000, sorry, which have requirement 1050 and availabilities are 200, 700 and 150. So these quantities are allocated simultaneously to these columns, as only one column is remaining, so we can put the quantity into the corresponding rectangles for availability. So in this one we can write 200, in this we can write 700 and in this we can write 150 directly. And the requirement for the column would become 0, as well as remaining availability will also become 0. So here you can see all the REM requirements are fulfilled. So it is the initial basic feasible solution obtained by least cost method. Now this solution can also be written in the following form, that from source A to destination 1 we can transport quantity 250 and cost for transport, such transportation will be 1000 units. Similarly, from source A to destination 2 we can transport 250 units and cost for this transportation will be 300. In same manner we can write all the transportations or all the allocations, and then by adding the cost for transportation we would get total cost, which comes out to be 1350. So total transportation cost obtained by least cost method is 13,050, and you can not say it is optimum cost or it is minimum cost, and it is a method for obtaining initial basic feasible solution. Now by using this solution we would obtain optimum solution by Modi method or by stepping stone method. Now I have made a comparison between northwest corner method and least cost method, and the solution that was obtained by northwest corner method was shown that total transportation cost was 15,150. So by comparing these two we obtained that the cost obtained by least cost method was minimum as was smaller as compared to northwest corner method. So we can say that least cost method provides an improved solution or same solution as compared to northwest corner method. Now we come to Vogel's approximation method, which is in short called as VAM, that is VAM. So it has certain steps. First step is select first row Then in first row find minimum and next to minimum cost and compute the difference. The difference would be positive, that is a smaller quantity would be subtracted from the larger one, and write it in the end of row. That means after the availability, and repeat the process for all the rows. In same manner, we have to select first column in next step, then find minimum and next minimum cost and compute the positive difference of these two costs and write it in the end of column. Step 2 is repeated for all the columns. Step 1 and step 2 can be performed in any order. There would be no problem if column is selected first or if row is selected first. There should be no problem. The result would be same. Now in third step, among the differences obtained for row as well as column, we have to find maximum difference. That means if we have 5 rows and 4 columns, that means we have 9 differences. Among these 9 differences, we have to select maximum one. Let it occur for cell I, comma, sorry, let it occur for the row J, or you can say it occur for column I. Then find the minimum quantity among all, sorry, the minimum cost corresponding to this difference. Let the minimum cost corresponding to maximum difference occur in cell I, comma j. Then first allocation is made in that cell. That means cell I, comma j. And in this cell we allocate the minimum of availability, that is AI, and the demand, which is BJ. Among AI or BJ, which should be minimum, that is allocated to cell I, comma j. And then again we repeat from step 1 to step 4 till all the allocations are not made. Now there's 2 points should be noted, that in case of tie among minimum differences, sorry, in case of tie among maximum differences, any of the difference can be preferred. That means if two differences are same, we can prefer any of these, and next step we can automatically get the next difference as maximum, or it may be changed. And in second point is that if the in a row or column the minimum cost occurs twice, that means in, suppose we are considering second row, and in second row two costs are minimum and same, that is 4 and 4, then the difference will be 0, but tie must be among minimum cost. If you say that first cost is 4, next is 7, and third one is 7, then difference would not be 0, difference would be 7 minus 4, that is 3. In case we have cost 4, 4 and 7, then difference will be 0. Now again in same manner we can represent the considered transportation problem in the form of following table. Here in rectangles which are like this, allocations are made. Here the difference between minimum and next to minimum quantity is noted. Then remaining availability and remaining requirements should be noted. So we are considering first the row. So in first row the minimum cost is 4 and next to minimum cost is 6. So the difference will be 6 minus 4, which is 2. In same manner, we can compute the difference for other rows. In next row, the minimum cost is 8 and next to minimum cost is 10. So again, the difference will be 2. Similarly, for row third, that is C, the difference would be 6, and for D, the difference would be 6. That you can see 2, 2, 6, 6. In same manner for column, the minimum cost is 4 and next to minimum cost is 9. So the difference will be 9 minus 4, that is 5. Then in next column, the minimum cost is 4 and next minimum cost is 6. The difference would be 2. In third column, the difference would be 2. In fourth column, the difference will be 8 minus 3, that is 5. So here we have computed the differences. Now among these 8 differences, we have to find maximum. Here you can see that two differences, that is 6 in third row and fourth row, are maximum. So we can select any of these. I am selecting first one, that is for row of source C, and corresponding to this difference we would obtain the minimum cost, which is 4. So here in this rectangle we made the allocation corresponding to this cell. The minimum availability is 300, sorry, the availability is 300.
सर फोर रो में भी तो मिनिमम लिस्ट और
Beta
मतलब
A. So here you can see the minimum cost is 4. Now availability is 300 and requirement is 350. So corresponding to it, minimum is 300. So here allocation made in this cell will be 300 and simultaneously subtract from availability as well as demand. So here requirement would become 0 and availability will remain 50. Now again we compute the difference ignoring the row of C. That means this row is not considered for calculation of requirement. Now for first row the difference would obtained same, 4 minus 6, that is 2. For second row 10 minus 8, that is 2. Third row we have already fulfilled its rim requirement, it is no difference would be calculated here. Then in next row 9 minus 3, the difference would become 6. In same manner for columns difference would be obtained 5, 5, 2 and 5. So here you can see that difference in first table, here the difference was 2. Now row 3 is ignored. So difference will become 11 minus 6, that is 5. Now among these, the maximum difference is this 6. Now corresponding to this 6, the minimum cost is 3. Now allocation is made in this rectangle. That means mean availability is 350 and demand is 200. Minimum of these two is 200. So here 200 units are allocated. And simultaneously it is subtracted from the availability as well as from the demand. So rim requirement for fourth column is fulfilled and availability for row D would become 150. Now for calculating next differences, fourth column will be ignored. Now the differentiate would be changed and you can see for first column, first row difference would be again 4, 6 minus 4, which is 2. For next row, the difference would become 11 minus 10 as minimum cost is 10 and next to minimum is 11. Fourth column is ignored, so its cost 8 would not be considered. The difference would become 1. For fourth row, the difference would be 11 minus 9, that is 2. In same manner for column, the differences are 5, 5 and 2. So in same manner, we can make allocations by repeating the process, and in last step we would obtain this table. That means all the rim requirements are fulfilled, and it is our initial basic feasible solutions obtained by Vogel's approximation method. In same manner, we have written the least cost method solution. In same manner, we can write initial basic feasible solution obtained by Vogel's approximation method. And then we compute the total transportation cost, which is obtained as 13,050. And if we compared it with northwest corner method and least cost method, we can see that Vogel's approximation gives an improved solution as compared to northwest, as well as the solution obtained by it is similar to the that one obtained by least cost method. But in some situation, it can provide an improved solution as compared to northwest corner method as well as least cost method. That means if no choice or certain requirement is given for obtaining initial basic feasible solution, then if no method is specified, we prefer Vogel's approximation method, as when we go for optimum solution it require minimum number of steps.